Okay, for today, we're talking about the normal distribution. We had briefly discussed it. I had just kind of put it up there quick and asked you to remember that the middle part between one standard deviation in both directions was 68%. This is where 68% of the data lies. All the people that are in here. That's about 2/3 of the people. I remember it as 2/3, even though that would technically be 67%, but it'd be 67.66666666, right? So it'd be 67. It's really close to 68. It ends up being 68. Put that away, please. Need a blank notability doc. Yes. That means that the standard deviation is 15. That means that from 100, if we go out 15 in either direction, then we get 115 and 85. And those are the scores where between those two scores of IQ, that's where 68% of all people are. Well, how about the other people? The other 30-something percent of people, 32%. Well, they're outside of that. Half of them are above it, half of them are below it. All right, in case you haven't caught on by now, here's what you should have figured out. If 68% goes from here to here, do you get that that would mean that 34% are from here to here, and another 34% are from here to here? Do you get what I'm saying there? So then if I want from 85 up, then I want this 34% of people are in here, right? And what percent of people are in the whole rest of it? From the middle up. That's this one. 50% of people are from the middle up. So this is 50% of all the people. This is 34%. And 50 plus 34 makes 84%. So there's an 84% chance that you'd get a person between 85 and infinite, or 85 and 150, which is higher than the highest IQ ever found. Okay, I'm going to leave this up here for a minute and see if you can use that same kind of logic to figure out what's the probability, what percentage, of picking a random person and them being between 100 and 130. From here to here. Between 100 and 130. Wouldn't it be nice if we knew both of these little things? We do know this one. Maybe you don't know that one yet, but you can figure it out. This one was 34. Don't just assume they're equal because they look equal sized. Totally not equal. All right, check with the kid next to you and see if they have figured out yet. How do you get that other spot? Yes. Hold on just a second. Pausing. Okay, so what were you saying again? How can we do this?
You can take the 95% and divide it by 2.
Take the 95% and divide it by 2. Why would you want to do that?
Because you're trying to find 100, 130, and 95% covers 70 to 130.
And if you just take half of it, if you want this right here, that's just half of the 95. I like it. That absolutely would work. So what's half of the 95? Did you figure that out? Raise your hand if you had 47.5. Awesome. There's another way to do it that's slower, definitely slower. But if you figured out that these two are 34s, it might be helpful to know how much these guys are. Did anybody figure it out that way? How much was that one? Can you verify, Mr. GL, that if I put, what did you say, Mr. 13.5, is he correct? Would that work with your number? All right. So if that's 13.5, then this is 13.5. And why does that help? Nope, sorry, that's not 13.5. This would be 13.5. This one's still 34. So 34, 34, 13.5, 13.5. That's getting hard to memorize. And that's really true. And so I'm not going to ask you to memorize all those because you can get them with a calculator and a little bit of dividing. All right, so let's do one more like this. Get a nice clean one. I missed. I'm going to drag it and cheat a little bit. There we go. Let's say that the average on this one is, we're going to go with temperatures outside. Okay. Average temperatures in May. These are average high temperatures in May. So let's go with 70. Would you agree not every day is 70 for a high? So let's say that it has a 5. What do you think I'm going to say? Standard deviation. So you take a typical day and the high temperature is within 5 of 70. All right, so I like to do like this. Let's say that that's 5 and that's 5. And then you'd have these two lines. Whoa, hold on. Yikes. Thankfully there's an undo button. Wish there was one of those for life. Dang it, didn't mean to say that. Undo. Okay. So you get that that means this goes 75 is one standard deviation above normal, 70 was normal, and 65 was the one that was one below normal. All right, so here's my question. What's the probability that tomorrow's high temperature will be between 65 and 75? Well, that's not that hard. Isn't that one of the ones you memorize? Which one is it? 68. That's 68%. I know that one. You just have to memorize that one. From one above to one below standard deviation, one standard deviation above to one standard deviation below, 68%. Yes?
Is that going to be the same for like high temperatures?
Yes. As long as it's called a normal distribution, yes. That's why it's powerful enough to memorize. Okay, then, next question. The weather forecaster is a little obscure and says, today, the high temperature will be 2 standard deviations above normal. What temperature will it be? All right. And then he says, the probability that the temperature would be higher than that is what? What is the answer to his question? He says it's going to be 2 standard deviations above normal. You already figured out that, that means 80. And that'd be like here. And I said, if he says, what's the probability it's going to actually be hotter than that? Well then, all of a sudden, you're asked about this. It'd be easier if I'd asked you this one. That wouldn't have been that hard. But I asked you above 80. Would be awesome if you had them all memorized. This was 34. This was 34. This was, who's got a short-term memory? 13.5. And this was 13.5. And that would, by the way, be 60 degrees. And then, dang, I need all the rest of them. But you can do it. You have all the information. You can either do it with knowing that from here up is 50, or with knowing that from here down is 50. Either way, you can figure out the probability it's above 80. That's this guy. If you're not getting this, think of it this way. The whole thing from here to here would be 50, so it's not that big. not 50, it's less. How much less? Subtract off some stuff. Who thinks they have it? All right, that's almost everybody. What do you think I should do? 50 minus, or did you do it a different way? How'd you do it? Okay. Well, here's 95. You're talking about this whole thing where we go out two of them, right? That's 95. And then you did what? So if this whole thing's 95, you're saying that this plus this together has to add up to how much? 5. And therefore, how much would this part be? 2.5. Raise your hand if you had 2.5. Awesome. Here's another way you could have done it. Do you get you could have done it with the 50 thing that I said? This was 50, but then I take off this and this. 50 minus 34 and minus 13.5. That way it works too. Okay. One more I want you to know. We've got the 2 up here. 68, and I'll put it back up here. Final answer to that question was 2.5%. Okay. But 68, next one out, 95. Who's got the last one memorized? We go out one more. Nobody? Okay if you don't, but you need to for the test. I know, this is tough, but honestly, this is one of the things I teach kids to rock the piece at. There's a lot of stats on it, and this one thing really does help. The third, 3 standard deviations out. So that's one more line out, which would be 85 and 85. Do you have all the data yet? Nope, but you have a lot of it. Anybody know what the number would be? You can do math to figure it out. Yes? Thank you, not 85. Oops. Picky. No, he's absolutely right. I do need to fix that, and it won't let me erase it or grab it, so I'll just erase it. Yes, that's 55. Thank you. All right, then I'll just tell you, and you need to memorize it. This last one, 99.7%. That leaves 0.3%. Think now, does that mean that the 0.3% is right here? Or is it over here? It's both of them add up to not 3%, 0.3%. That means how much on each side. If you want to know everything, just memorize that the 0.15 is the last little tail end. And you know what that is? If this was IQ, that would mean genius. That's where you have to be. 3 standard deviations up from normal. What's normal again on IQ? 100. You know what standard deviation is? 15. 15 times 3? 45. So a 145 is for sure genius. In fact, they actually say you don't have to be quite 3 standard deviations. I wish it was as simple as 3 standard deviations up, but if you're just a little under that, you still can be considered a genius. But 145 would definitely be a genius. And that means top 0.15%. Not 1.5, 0.15. And same down here, because these two together have to add up to 0.3, and that's what makes the total 100. 99.7 plus a 0.15 plus a 0.15. There we go. Okay. Now, how could you do this on a calculator? That's the last thing I have to teach you today. So there's a cool little program that does this, and you're going to learn how to use that. Grab your graphing calculator, and we're going to find the VARS button. Not something you use real often. You know what VARS stands for? No, it's varsity. I'm just kidding. All right, technically, it's not the vars button itself, it's what's above the vars button. What do you think the distur stands for? No, it means distribution. Okay, and of the types of distribution, it seems like we would want normal, and we do. But it is normal CDF that we're doing today. Normal CDF. And hit enter. I'm going to pause for a second. So, I'm guessing it's going to be one of those little probability things. I think the probabilities are high that I will have about 4 people who don't have this when they hit CDF. Raise your hand if yours does not show this menu. All right. I thought 4, and I've got 1, 2, 3, 4. Yes, nailed it. Okay. So, oh, great. I was close anyway. Okay. So if yours doesn't show this, then I will help you in a minute because you just have, yours is an older system that it doesn't like ask you the questions. And you'll see in a minute, this is asking you the questions and it's going to fill in this little thing. So if you have an older calculator, you got to wait 1 step. All right. Okay, fine. So lower, upper, and here's what we do. Here's a typical question again. This is back to the temperature ones where the middle one, the mean, is 70. Are you with me that we're talking about 70 is the middle of this one? What if I said I wanted the probability that my temperature was going to be between 70 and 100 as the high temperature for today? A randomly chosen day because we happen to be doing it today. All right. So then I would go lower 70. So I'm going to move this over just so I can type in my calculator. 70. Upper. Do I really just want to pick a number like 80? No, that'll actually tell me the probability it'll be between 70 and 80. I want to pick infinity. Between 70 and infinity. How do I say infinity? Well, you can't really, but you can say 1 times 10 to the power of 99. And it'll say, when I do that, 1 times 10 power of 99. That's also later going to say EE 99, just so you know that that's what that would mean. EE would mean 2 times 10 to the power of. Okay. Now take a guess what they also need to know besides the low to the high. We haven't told it the standard deviation, but that's the next one. Do you recognize the symbol? That's the standard deviation symbol. What did I say our standard deviation was? 5. Put that in. Now, I happen to be picking from the middle up. But I didn't get asked for the middle one yet, did I? That's the last thing they want to know. That's where you put the average, which is 70. I'm realizing now I probably shouldn't have started with 70 just because that might be confusing you right now. I'm going from 70 to infinity. The average is 70. The standard deviation is 5. And why the heck does it say paste? Because it's going to paste these numbers into the formula, which actually the formula looks like that. If you're going to have to use a calculator and put it in 1 by 1, that's what you need to type. And by the way, if you can't read them, these are little commas right here. So if you have an old calculator, you are typing in 70, which is from the lower end, to infinity, which is the higher end, comma 70 is our average, comma 5 is our standard deviation. And then if you're got one of the newer calculators, you can just hit the enter button and it'll calculate it for you. And there it is. Take a wild guess what 0.499999999 rounds to. 0.5, shouldn't it be? 50% of the data goes from there to there? Yeah, but I would have known that one just because I'm smart. What if I said, what's the probability the temperature will be between 70 and 73 degrees? That wouldn't be as easy. But yet, the calculator can do it really easily. Probability, it's going to be between 70 and 73 degrees today. Now I'm going to go back to my above the vars. Remember, we're doing the second one, normal CDF. from 70 to 73, where the average is 70 and our standard deviation is 5, and I hit paste, and I hit enter. See how quick that is? Boom, 23% chance. I'm rounding, but isn't that quick? All right. So riddle me this. I think it's going to be kind of cold. What's the probability it's going to be between 60 and 65 degrees? Probability it's going to be between 60 and 65 degrees. And there we go. 14% chance if I round it. Raise your hand if you got 14% chance. Okay, awesome. All right, I'm going to give you a whole new problem. This is going to be a word problem. I'm just going to say stuff to you about a situation. And I want you to figure out what the probability is. You're going to use this normal CDF thing. Okay? All right, so here's your situation. You have a newt farm. Newt. Newt, not nukes, newts. These are rare furry newts, and you're going to be making tons of money when these go big. Okay, so the little furry newt colony in your basement, you take the average length, and the average 8 inches long, and the standard deviation is 1.5 inches. You grab a random newt. What's the probability it's between 9 and 9.5 inches? Between 9 and 9.5 inches. Okay. The lower, 9. The upper, 9.5. What was the average newt? 8. What was the standard deviation? 1.5. Only a 9% chance. Make sense? All right, let's see if you really get the infinities and maybe the other end of infinity. Let's say that the randomly grabbed newt was at least, which means 9 inches or bigger, at least 9 inches. A randomly chosen newt. I can't speak. Randomly chosen newt was at least 9 inches. So at least 9 inches means that you're going to go between 9 inches and infinity. How do you put in infinity? 1 times 10 power of 99. Other numbers stay the same because the same average and the same standard deviation. You hit enter, and I hit enter. 25% chance. Raise your hand if you had that one right. Okay, awesome. And now the last one goes the other way. Your friend really wants a really small newt because they think the cuter ones are the smaller ones. So she really wants one that's 7 inches or smaller. What's the probability you reach in and grab a random one that you're going to get a newt that's 7 inches or smaller? 7 inches or smaller. You might think you'd start with the lower limit of 7, but no. What's the lower? -1 times 10 to the power of 99. How many of you figured out to use a huge negative number? That was smart. If you didn't catch that, copy it now. Try it again. -1 times 10 to the 99. So that's basically like saying negative infinity. Now, could you argue that the smallest newt you'd ever have would be 0? Yeah, I could see that argument. The safest thing to do is put in this, and I bet you if we'd used 0, we'd probably get the same answer. All right, upper limit, 7. She didn't want any bigger than 7 because the big newts are just scary. So then, final answer, only a 25% chance. Raise your hand if you had 25% on that one. Okay, good. All right, I think you're getting it. Let's do one more example. Let's say that this is weights of the guys on the wrestling team. Do you get that they wrestle in different weight classes? Okay. Let's say that the coach has an average, you want to go into normal CDF right now. The coach has an average weight of the guys on the team is 100 pounds. Standard deviation is 25 pounds. He grabs a random kid. What's the probability he's at least 70 pounds? Average weight was 100. Standard deviation was, what did I say again? For standard deviation, 25? Was 25 a standard deviation? Yes. Okay. At least 70. All right. You should have gone in here. You should have said from negative infinity until 70. And you should have said that the average was 100. And that it's a 25. Standard deviation. 11.5%. We could round it to 12% chance. Did I do that wrong? Okay, help me see where I did it wrong. I did between 0 or negative infinity and 70 with a 100 and a 25. Did I do something wrong there? Oh, I said at least 70. I meant 70 or under, but that is not what I said. You're right. I said at least 70. Sorry. I'm going to go retype it in and do it right. I meant one thing in my head, but I said something else. Okay, so at least 70. The lower would be 70. The upper would be infinity. So I could say 1 times 10 to the power of 99. $88 or 88.5%. Depends on where you're going to round. Raise your hand if you had that one right. Okay, sorry about the little misspeak there. So there you go. You've learned about the normal distribution. Now I want to give you an example of not normal. Don't worry, I'm not going to point to you personally. All right. But I'm going to say your hair out there is not normally distributed. I want you to think about why. If I grab a random kid in here, normal distribution would mean, let's say that the average hair is 12 inches long. Okay? I know some of you are like, whoa, that's way too long. For a lot of the girls, that's way too short. Do you get where I'm going here? Do you get that there's a lot of boys with short hair and a lot of girls with long hair? And there's not that many people that are in the middle. Do you get how this implies, if you do this right, you go one standard deviation in both directions, you get 68% of you. 68% of you are not in there. Not many of you are in there. Most of you either are a girl and have long hair. I know this is totally sexist, but I'm just dealing with the girls that I have in the room. Almost everybody has long hair. Okay? And I didn't say everybody, almost. Then the guys are on the other end, so this is not a normal distribution. Do you get that it would actually, in this class, be that there'd be a clump of guys with short hair and a clump of girls with long hair, and it'd be more like that? All right, so there's a whole bunch of different kinds of distributions. Not everything is a normal distribution. So I'm trying to say, granted, a lot of things are normal. But if we're talking in this room, right here, right now, that hair length is not normal distribution where there's actually not many people in the middle that have exactly 12-inch long hair. Okay. You get what I'm saying there? Not everything's normal is the point. Okay, now grab your the Schoology quiz, which is for today, and I'll help you start it. I'll pause for a second when we do that. Okay, so here we go, number 1. Would you read the sentence in italics that's right here? Answer each of these questions without using a calculator. Does that mean for the whole thing for the rest of time? No, just on problem 1. You need to know these from that chart, which was, what was in the middle again? 60 what percent? 68%. What was the next one out? The whole thing together made a total of 95, and then the last one, 99.7. Very good. And then the last little tag ends on each end. Do you remember? 0.15. Very good. 0.15 on the high end, 0.15 on the low end. Okay. So, what percentage of skiers finish the run in between 41 and 49? It seems like it's going to be super hard without a calculus. It's really not. Right down the middle is 45 with standard deviation of 4. So I go up 4, and that's going to be 49. I go down 4, that's going to be 41. And look at that, 41 to 49, just like they said. So what percent is in between there? We already said it. 60 what? 68 is the first answer. All right, less than 45. That means from here down. You ought to know. Yeah, that's just 0.5. Okay, keep going. I think you can handle this. The next problem, you can use the calculator. And you'll do the normal CDFs just like we were doing. All right. And that's all I have for you for today.